Okay, so this is lesson 11, continuity and differentiability. And just a couple things to review. Back when we learned about differentiable functions and them needing to be continuous at specific points. So remember that if a function is differentiable, then it is continuous. And if a function is continuous, it's not necessarily differentiable. So on the bottom here, you can see some examples of functions that are not differentiable. All right, for a function to be differentiable, three things: f of x, or the function, right? It has to be continuous. There should not be any sharp turns and no vertical tangents. Remember, sharp turns, vertical tangents. That would mean that the function is not differentiable at that x value. Alrighty, so let's jump right into the first example. And with our first example, what we want to do here is we want to find the value of a and b that make f of x differentiable. So remember that we just went over, in order for a function to be differentiable, it should be continuous. So we're going to just jump right in and do our continuity test. So in order to test for continuity, remember that the value, in this case, our value of interest is 1. So we're going to check to see if 1 is defined into our function, and 1 cubed is, of course, 1, so it's good to go there. Let's just jump right in and test the limits, right? So we'll say that the limit as x approaches 1 from the left side. Sorry about my handwriting here. And I want to use the left part of the function. So that would be oh my goodness, x minus 2 squared plus b, right? And then we also want to test the limit as x approaches 1 from the right. And here we'll use the right part of the function, which is x cubed, okay? So plugging in 1 from the left side of the function, remember we're plugging this in for x. So 1 minus 2, that's going to be negative 1. And when we square negative 1, we're going to get 1. 1 times a, of course, that's just going to be a, and then plus b. That's what we get out of that limit right there. Okay, if we plug in 1 for the, as x approaches 1 from the right side here, 1 cubed is, of course, going to be 1. And remember, of course, based on our continuity test, in order for the limit to exist, that indicates that the left-hand limit should, in fact, equal the right-hand limit right there. But that leaves us with some unanswered questions, right? What is A, what is B? And in fact, that's what the question is asking for here, right? So in order to figure that out, what we want to do is let's look for the derivative of this function before we plug anything in. So let's see, can we derive this function, right? Because we're looking for the values of A and B that make the function differentiable. So let's derive it. And first part of the function here means that I'm going to just use our power rule, which means that that's going to become 3x squared, right? Of course, with that condition is x is greater than or equals to 1. And then the bottom part of the function, a and b, remember, those are just going to represent constants. So we're going to go ahead and use a power rule here in our derivative. Remember, we're multiplying that 2 times that a, right? So that's going to give us 2a. But because of that exponent of 2, it looks a little bit like a chain rule as well, right? So, move that 2 over there. We'll take, derivative of the outside. We'll go ahead and we'll copy the inside, right? This becomes a power of 1 there. And then times the derivative of the inside, which is really just 1. Okay? And if we derive b, which is a constant, we're going to just get 0. Okay? So this is x is less than 1. And we end up with this function here, right? Now, we don't really need that 1 hanging around there, so feel free to just get rid of that, sure. And what we have now is a little bit easier to read, no? Easier on the eyes, I guess. Okay, so x is less than 1. And all right, so now that we have this written out, we are ready to do the same thing, right? Does the limit exist on the left-hand side and on the right-hand side? And this is going to help me find those values of A and B that make the function differentiable. So I'm going to go ahead and say the limit as x approaches 1 from the left still. That's using the bottom part of the function, which here we just get 2a. We end up with x minus 2. And we'll also do the limit as x approaches 1 from the right, right? And we want to use that right part of the function. It's just 3x squared. So going into that now, right, we're going to go ahead and say, hey, well, what are we going to get on the left-hand side when we plug in 1? 1 minus 2, remember, going in for x, that's negative 1. And when we multiply that negative 1 times 2a, well, that's going to give us negative 2a. When we plug in 1 over here, 1 squared is 1. Multiplying that by 3, we end up with 3. So what does that mean? That means that we end up with, let's rewrite over this. This is negative 2a equals to 3. This is great because this is going to help me find the value of a, right? And we learned that a is basically going to be negative 3 over 2. So if we take that value of a, plug it into this guy here that we had earlier, whoop, right? That's going to help us find the value of b. So let's see, we got negative 3 over 2 plus b is equals to 1. Remember, if we want to isolate b, well, we're just really going to be adding 3/2 on both sides, right? And let's do this one in slow motion. Why not? So this is really 1 over 1 plus 3 over 2. Remember to get a common denominator, which means we'll have to multiply by 2. And that means we'll end up with 2 times 1, that's 2, right? Plus 3, that ends up being 5 over 2. So we end up with a b value that is 5 over 2. Okay, a value of negative 3 over 2. And that's how we'll find those values of a and b that make the function differentiable. Okay, we're going to do a few more just so you all really get a clear understanding. All right, let's take a look at this one here. This is a number 2 question. And let's do the same process, right? Well, if we're going to do the same process, what we're looking to do here is we want to go ahead and try to take the limit as x approaches 2 from the left. Remember, that point of interest there is 2, right? We're going to use the left side of the function, which is just x squared minus 6x plus b. And we'll also take the limit as x approaches 2 from the right side. And that's going to be x squared plus 10. Alrighty? Keeping in mind that a and b are just constants, all right? Plugging into 2 squared, right? That's 4. If we plug in a 2 here, negative 6 times 2, that's going to give me negative 12. And b, well, isn't that just b, right? We're not really sure what that is. So that's going to be negative 8 plus b right there, okay? All right, so we're going to leave it like that, put that guy on hold, and now go to the next piece, right? What's happening as x approaches 2 from the right side? Well, as x approaches 2 from the right side, we're going to plug in 2 again, right? So 2 squared, remember that's just 4. And that was an a in the front. I know it looks kind of sloppy. So this is 4a plus 10. Alrighty. So what does that mean? Remember that in order for the limit to exist, according to the continuity test, these two things must equal each other. So we're basically getting that 4a plus 10 should equal negative 8 plus b, or maybe it's easier to write b minus 8, right? Maybe that looks a little nicer to you. And just like last time, we might end up having to use this a little bit later on. So, um, let's make sure that we have it stand out in our work, okay? All right, so we just figured out that this function is continuous if and only if these two limits are equals to each other. What values of a and b will make this function differentiable? Well, we better derive it then, right? So let's go ahead and derive it. When we derive this function, we're going to use a power rule. Remember that a and b here, those are constants. So power rule would be 2 times our a value, right? X becomes power of 1. And when we derive 10, that's just going to become a 0, right? So our condition there is still x is greater than or equals to 2. And hitting that bottom side now would give us another power rule. So that's a 2x down there minus 6. And b representing a constant, again, just going to give us 0. So this is when x is less than 2, okay? And let's go ahead and do the limits here, okay? So we'll say the limit as x approaches 2 from the left, right? We'll use the left side of the function, and that was going to give us our 2x minus 6, right? And we'll also do the limit as x approaches 2 from the right, which is coming from that 2ax. Alrighty, so let's see what we get. If we plug in 2 into each of these, left hand and right hand limit, what do we get on the left side? Let's see. 2 times 2, no, that's 4. And when we do 4 minus 6, we should end up with a negative 2. What do we get on the other side? Let's see. If we plug in 2 in for x, we know that this 2 and this 2 is going to give us 4. Well, we end up with 4a. Okay, so what does that mean? That means that in order for the limit to exist, remember that these guys should equal each other, right? So that means that 4a is equals to negative 2. And if we're looking for a, we'll divide by 4 on both sides. And we end up that a is equals to negative half, okay? Now, once you find a, remember to come right back up into that guy right there and plug in your a value, all right? So we all know what half of 4 is, right? We know it's 2, but don't forget about your negative, really important there. And that's going to give us negative 2. Let me see if I can squeeze this in on the side. So that'll give us negative 2, all right, plus 10, and that's equals to b minus 8, right? Okay, let me go ahead and add 8 to both sides. That way I can isolate my b, right? And then we end up with a b is, what is this? Let's see. We got negative 2 plus 10. Well, we know that negative 2 plus 10 is 8. We also know that 8 plus 8 is 16. So we get a value for b of 16, all right? And that's what we're looking for here. We're looking for values of a and b that make these functions differentiable, okay? And a lot of the times, these functions are piecewise functions, like the ones you see here, okay? So that's how this works, all right? Now, it is possible, I'm just going to skip right over this one because we all know, like, if you get a question like this, hopefully, you go through the limit process, go through the continuity test, right? And then when you get down to the derivative part of it, right, and you go to derive, well, what happens there? Remember that you got to change that guy into a power, right? So this is really a x to the negative 1. Move that up to the top, okay? So keep that in mind. And then you can go ahead and fill in your derivative here, and then you go from there, okay? So pretty confident that you guys can pick that up on your own. All right, so let's look at another example, okay? Now notice the instructions change here. The instructions here, they say something slightly different, right? It says determine if f of x, this is our function, determine if f of x is continuous and or differentiable at a given point. So it is possible to have these functions, not be continuous or continuous and also differentiable like the ones we've been seeing. It's possible to have functions that are continuous and maybe not differentiable, right? So why? What does that even look like? A continuous function that's not differentiable. Look, right here, that guy right there. That's a continuous function, but it's not differentiable right there at x equals 0, okay? So that's a perfect example. I know it's not well, it could be written as a piecewise function. We've seen that before, but anyway, this is a good example of an MCQ question on your AP exam, all right? And the answer choices could be anything like continuous, not differentiable, continuous and differentiable, continuous only, differentiable only, things like that, okay? So neither, right? So anyway, we're gonna go into it, okay? So determine if this function is continuous. First step is, was it even continuous? So we go right into the continuity test, all right? Value of interest here, that's -1. And so we say the limit as x approaches -1 from the left, right? We're using the left side of the function, and that comes from -x minus 4. All right, we're also going to test the right side of the function. So limit as x approaches -1 from the right, okay? All right, so what part of the function is that? That's the part on the top, right? So that's x squared plus x minus 3. And all right, let's plug in -1. When we plug in -1, we get -1. Ooh, actually, this is kind of interesting, right? We get a negative here, and then we get a -1, and then we get a -4. Oh my goodness, all these negatives. Well, negative, negative, that's positive. So we end up with a +1, right? -4, which is really going to give me -3. Okie dokie, let's move on to the next part. -1. And when we plug in -1 here, remember that -1 squared is 1, all right? Plus minus 1, right? So that's -1 right there. And then -3 is what we have. So these guys cancel out, and that's going to leave us with -3. What do we think? Is it continuous? Yes, it is continuous so far, right? So we have to keep going, right? So the question here is determine if this function is continuous and or differentiable. So we know it's continuous. It's a differentiable. All right. So in order to find out if the function is differentiable, we go into its derivative, right? So same concept that we've been doing. We'll derive here straight up power rule. It's going to give me 2x plus 1. Alrighty, and conditions here. Let's see. X is greater than or equals to negative 1. And then the bottom part here, well, what's the derivative of negative x minus 4? This one's pretty light work, right? It's just going to give us negative 1 because the derivative of negative 4 is just 0. So x is less than negative 1. That's our condition. And we go right to it, right? Let's test those limits. So x approaches, what is this, negative 1. Let's go from the left side first. Alrighty, limit as x approaches negative 1 from the left. What am I plugging in? Well, I'm plugging into the left side of the function, but the only thing there is negative 1. And now we go to the other part. What's the limit as x approaches negative 1 from the right side, okay? And we plug in the right side of the function, 2x plus 1. Okay, so when we plug in negative 1 into this left side of the function, there's no x for me to plug anything in, which means the limit is, in fact, just going to be negative 1. Alrighty, so over here, when we plug in negative 1 into the right side of the limit as x approaches negative 1 from the right, when we plug in negative 1 into that limit there, negative 1 times 2 is negative 2, right? And negative 2 plus 1 is in fact negative 1. What do we think? Did we get the same value? Yes, which means that this function is differentiable, okay? So I mentioned to you that this is a really good MCQ prep question because the answer choices are interesting, right? Differentiable but not continuous, or continuous and not differentiable, or continuous only, differentiable only. The way they can word it, I mean, is anybody's guess, but this is a really good example. In the case of this question, the answer would be continuous and differentiable. Okay, let's look at, I think, one more, and I think you guys got the hang of it. So last question here, just to make sure everybody's got it. All right, so same directions. Determine if the function is continuous and or differentiable. All right, and feel free to pause the video. Feel free to try it on your own and see if your answer matches mine. I'll go ahead and work it out nevertheless. All right. So hopefully you paused. I have high hopes for you guys. But let's check our work, right? So is this function continuous? That's where we usually start, right? And hopefully the value that we tested was 2. So limit as x approaches 2 from the left. What are we plugging in? Oh, the left side of the function. That's 4 minus x. Alrighty, now we'll test the right side of the function. Limit as x approaches 2 from the right side. And we plug in the right side of the function, right? Which is just x squared minus 6x plus 10. All right, so now that we got that in place, we're ready to find those values, right? Plug in your 2's. So what's 4 minus 2? Oh, it's just 2. Okay, how about the other side? When we plug in 2, what do we get? Let's see, 2 squared, that's 4. 2 times negative 6 is negative 12, just to keep us on our toes, right? And then plus 10. All right, what do we get here? Let's see, 4 minus 12, that's negative 8, all right? And negative 8 plus 10 is in fact positive 2. Okay, so far this looks good. What does this mean? It means that this function, f of x, so far is continuous, right? Okay, but is it differentiable? How do we figure that out? We figure that out by taking its derivative, right? Okay, let's take its derivative. Let's see, power rule on the top here. That's going to be 2x minus 6. Remember that the derivative of 10 is just 0. And then when we derive 4 minus x, very similar to the last one, 4 is just a constant. Negative x, when we derive that, we end up with negative 1. Ooh, I almost forgot my conditions over here. X is greater than or equals to 2. X is less than 2. Alrighty. These don't usually come out as FRQs, so this is 100% multiple choice question prep, okay? Really common multiple choice questions here. All right, so lost myself. Oh, we're testing to see if the function is differentiable. So let's plug this in, right? Limit as x approaches 2 from the left. Well, the only thing I can plug in on the left is this negative 1 right there. And then the limit as x approaches 2 from the right. All right, what do we get there? Let's see. That's a 2x minus 6. Okie dokie, what do we get? Let's see. Well, when we plug in R2 into the left side limit, or the left-hand limit, better said, there's nowhere to plug it in. So we end up with a negative 1. And when we plug into the right-hand limit, right, 2 times 2, that gives us 4. And 4 minus 6, what's that going to be? Negative 2. So what do we think? Are these guys equal? And the answer to that is, well, it's no. And what does that mean? Well, we know that when they're equal, they're continuous. And we know when they're equal, they're differentiable. So when they're not equal to each other, it means that it's not differentiable. Okay, so the answer to this one, if it's an MCQ question, would be continuous, not differentiable. All right, pretty simple, to the point, and that's pretty much the way it works. Okay, all right, so hopefully you guys get the hang of it. And anyway, that's kind of the way this works. All right, and hopefully you guys understood lesson 11. All right.